Okay. We should be where? 4:30. Okay. Okay. You will use this theorem, Pythagorean theorem, in this lesson. I'm not going to say much about it. It's the Pythagorean theorem. Basically, it says take your leg and what? Square it, add your other leg squared, and you get the hypotenuse squared. And sometimes we just make it easy. A squared plus B squared equals C squared. But A is known as, and B is known as legs. These are your legs. And C is known as hypotenuse. Opposite the right angle is the hypotenuse. Okay? That's all I'm going to say. You okay? Did it 100 times last year in geometry. No, 2 years ago in geometry. My fault. Okay. All right. Next one. And by the way, I'm going to say it to you now. I'm sorry. I don't really like this that I put 4 slides on one page because it's really hard to read. At least it is for my eyes. Your eyes might be better. They probably are. But I just don't like it. It looks so small. Here are your trig ratios. Sine, cosine, tangent are the big 3. The reciprocals over here, we don't use them much, but when they show up, we usually go this way. When that shows up, I usually go back to this, and I'll show you how later. But sine, cosine, tangent, these are the ratios, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. There was an easy way to remember that.
Soh Cah Toa.
If that helps you, then write it. Okay? So this is your Soh, opposite over hypotenuse, Cah, and then Toa. Just a quick, helpful hint on how to use the ratios, or just remember the ratios, okay? The other thing I think you should do, I think you should write this down. What's the reciprocal function to sine?
Cosecant.
Okay, cosecant. I would abbreviate it like this. Cosecant. This is going to be what reciprocal function? Secant. Abbreviate it like this. This is what? Cotangent. Okay. I think these two make sense. Tangent, cotangent. That makes sense. These, to me, when I was in high school, I thought, why does the S and the C go together? Why does the C and the S go together? It seemed like it should have been SS, CC, but it just didn't work that way. So then in high school, I remembered it as, it's the opposite of what I think it should be. That's the way I did. Don't know how you're going to do it. You might just memorize it, and you have it. But anyways, you do what you got to do. Just tell me this, though. What's the ratio of cosecant? What over what? Hypotenuse over what? Opposite. See, and this gets confusing because you have to always remember the ratio. And I usually just go right back to sine if I see cosecant. If I see secant, I go right back to cosine. Because it's just easier for me to remember. Okay? All right. That's all I have to say on that slide. What's this? What's that funny letter? What is it? Say that again. What did you say?
Why is it different?
What did you say?
I said theta.
Oh, theta. Okay, sorry. No, this is the Greek letter for alpha. Okay, so, alpha kind of does one of these little numbers. Anyways, it's alpha. This one is what?
Theta.
This funny letter is beta. What's this one again?
Omega.
That's omega. What's this one?
Theta.
That's theta. Okay. So these are the Greek letters they use a lot, just so you know. Okay. All right. Here's a triangle. I gave you side A, B, C. I gave you alpha right there, and I gave you beta right there. What I'd like you to do is this. What is sine of alpha, sine of beta, tangent of beta, and cosecant of alpha? Put the answers on paper. I'll ask you in 30 seconds. Will. Sine of alpha is what over what? Don't tell me the letters, tell me the words opposite hypotenuse, Jason.
Opposite over hypotenuse.
Okay, so it's opposite over hypotenuse, and you're gonna tell me the answer is what?
A over C.
A over C. He's right, it's A over C. All you gotta do, guys, is look for alpha, find alpha, it's right here. Opposite over what? Hypotenuse, it's A over C. That's it. Okay? I won't do that anymore, just tell me the answer. Carly, what is sine of beta?
Well, it'd be B over C, so we just.
Yeah. B over C, you got it. Kyle, what's tangent of beta?
B over A.
Come on over. B over A, he's right. Cosecant is that oddball function. It's the reciprocal of which one?
Sine.
Sine. Connor, what's cosecant of alpha?
B over A.
He says B over A.
Nope. C.
Did you say C or B?
C.
C over A. C over A. Now here's the deal. If I see cosecant, here's what I think. Cosecant would be the reciprocal to which one? Sine of alpha. But if I know what sine of alpha is, which I do, it's right there. It's what? A over C. Then this would have to be the reciprocal C over A. Yeah? That's my thinking. I go back to sine. I go sine of what angle equals, well, sine of alpha equals A over C. So flip it and you get C over A. That's me. Now some of you might have done this. Did anybody do this? And that is, did you go like this? Cosecant would be hypotenuse over what? Opposite. Did you do that? Is that what some of you did? No? So you guys did this? You figured out what sine was, you looked up there, I suppose, and you flipped it, right? Okay, good. Okay, find the 6 trig functions of theta. Theta hides right here. Here's theta. Okay. Go find the 6 trig functions. I would write it like this, just so you know. Sine of theta equals what? And then right below it, I'd write this one. Because these answers are just what? They're just reciprocals. So if you get that answer, flip it, and you got that answer. Right? So is anybody looking and going, I feel like I'm missing something?
C squared.
You're kind of missing a side, aren't you?
Yep.
So how are you going to get that side? Yeah, it's a right triangle. Pythagorean theorem, right? Pythagorean theorem would give it to you. Hypotenuse squared equals leg squared plus leg squared. I don't know this leg, so I'll call it x.
10 squared.
10, yeah, my fault. Yep, you're right. 10 squared is 100. You good? Square root of both sides. Is there a perfect square
No.
that goes in 84? 4 does. 4 goes in there what? 21 times. So the answer is? Got it. Missing side of your triangle is 2 square root of 21. Okay, now go do your 6 trig functions. Do not use your calculator. Don't tell me the missing side was 9 point blah, blah, blah. Okay? You're not going to get to do that on their test. It's non-calculator.
No, this is short.
This is on the non-calculator.
calculator version of the test?
Guys, once again, this is on the non-calculator version of the test. You have to be able to use your square roots and work with them. Sine and cosecant were pretty easy, weren't they? Sine, opposite over hypotenuse would be 4/10. Better reduced to get what? 2/5. Cosecant, 5/2. There. Those two take no time at all. Well, maybe a little time. Cosine of theta, secant of theta. This will take you longer because now you got radicals, okay? So this one, what's it going to be? What over what?
Two squared is 21 over 10.
2 squared is 21 over 10, gotcha. 2 squared is 21 over 10. But 2/10 reduces to what?
1/5.
Square root of 21 over 5. Is it okay to have a radical on top? Yeah, you're done. Okay? This answer will be that answer flipped, right? So there'd be 5 over the square root of 21. Is it okay to have that on the bottom? No. Get rid of the root. How? Okay, I said how. Multiply by square root of 21. Then you get 21 on the bottom. And what on top? By square root of 21. Okay? Now, if you can do this in your head, I don't require you to show that because I know half this class can do that in their head and get that answer quick. But I'm showing my steps just so everybody sees what I'm doing. Okay? So tangent of theta, Paul, is what? What'd you get for tangent?
It's I didn't simplify that.
Well, just
That
tell
would
me.
be 2 square roots of 21 over 21.
Okay, you're giving me the answer, I think.
Yeah.
Can you just give me
Yeah.
opposite over adjacent?
4 over 2 square roots of 21.
And then I would probably reduce 4 and 2 to what?
2.
2 square root over square root 21. Now Paul is going to rationalize it, and he already did. What is it?
2 times square root of 21.
Over
21.
over 21. Is 220 over 21 reducible?
No.
No, you're done. Okay. When you do cotangent, reciprocate it. But if you reciprocate this, the radical goes back to the bottom. Look right here, guys. What if you reciprocated that? That's your answer. So I wouldn't reciprocate this. I'd go back here. Then your answer becomes square root of 21 over what?
2.
2. You're done. If you reciprocate that, you're going to get this. It's just going to take you more time. Okay? All good? Don't use your calculator to say this side is 9 point ... Don't do that. It is a non-calculator problem on the test. You might as well get used to it. Don't use your calculator. All right. Here are some special triangles you worked with a ton last year. Do you remember this one? This is called the what triangle? 45, 45, 90. Okay.
Yeah.
This is called the what? 30, 60, 90. Okay. Now, your teacher last year probably spent a lot of time trying to prove why these numbers appear on this. And I can put all kinds of numbers on this, but here's the deal. Opposite of 45, the legs will always be
Congruent.
the same. Yeah, 1, 1. I could say 2, 2, 3, 3, 4, 4. Okay? But whatever I do, I can use the Pythagorean theorem, and this side will always be what?
Whatever it is,
Square, yeah. Right, but it's going, in this case, it's the square root of 2 with 1, 1. But if I did change it slightly on you, and this is why we wouldn't do this, if I went like this, if I called this leg 4, and I called this leg 4, do you know what the hypotenuse is? It ends up being, 4 times the square root of 2. Because all it really is, guys, is your leg, whatever your leg is, in front of the square root of 2. That's all it really is. But we're not going to get that much into it. I just want you to know your ratios or your sides of the sides of your triangle are, here we go, 1, 1, square root of 2. Okay, write that down because you can't really read it. It's too small. Okay? The 30, 60, 90, this one's nice because we made the hypotenuse what number? We made it 2. So let's make it 2. And then the side opposite of 30, we made it's 1. But if you look at it, the hypotenuse and this side opposite of 30, what about the answer? Compare it to that. It's half. So whatever this number is in a 30, 60, 90, the short leg is half the hypotenuse. And we did call this leg the what leg? We called this the short. The short leg is half the hypotenuse. Or you could double the short and get the hypotenuse. Okay. Now this is called the what leg? Long leg. Okay. Now the long leg, if you use the Pythagorean theorem, you're going to get square root of 3. I'm not going to show it, but that's what it is. Now one thing I want you to know is this, and you were probably told this several times. If I change this number to 5, then the hypotenuse would be 10, and this long leg would be 5 square root of 3. Okay, that was the relationship with the 30, 60, 90. But to keep it really easy, we're going with what numbers?
1, 2.
We're going to go with 1 for the short, 2 for the hypotenuse, and square root of 3 for the long leg. The long leg is opposite of what? Ooh.
60.
Yeah, opposite of 60 is the long leg. Opposite of 30 is the short leg, and then opposite of the hypotenuse is 2. Okay? The next slide, you can't see anything, can you?
No.
Okay. Ready? Do that problem. Tangent of what angle equals 1 over 1? Use the previous slide, guys. It's either a 45, it's a 30, or it's in a 60. Okay, here's the deal. I don't think this one was hard for you. I just want you to know this. When I see tangent of an angle equals a number, I always make it a ratio 1 over 1. Now, remember the top number stands for what word? Tangent is what over what? Opposite over adjacent. Okay. Now, you have 2 triangles to pick from. The only triangle that has a 1 and a 1 in it is what? 45. Okay, so there's your 45. Okay. So opposite of 45 is 1. Adjacent is also 1. It's got to be 45, correct? Okay. That was not a hard one, I didn't think. So I'm going to just make them slightly harder as I go. Do that one. You only have 2 triangles to pick from. Look at the previous slide. Go back to your previous slide. So why do you think I put a 30-60 down, not a 45-45? One of those. Dead giveaway. You saw the square root of 3? It's a 30, 60, 90. Okay. Well, now that I saw that, I draw this, and then I think to myself, is it the 30 or is it the 60? And I want the sign. Now, sign is opposite over hypotenuse. So if I pick this one 60, that's the opposite. That's the hypotenuse. Did it work? It worked. If you would have picked 30, it would have been 1 over 2. It didn't work. So it's got to be 60, right? Okay. Try that one. Secant of 2 squared root of 3 over 3. Did you see the square root of 3, right? It's either this one or it's this one. Raise your hand if you will. Can you tell me how you thought about this problem going into it? Go ahead.
Switch it to cosine.
Okay. Why'd you do that?
I think cosine's easier to work with.
Okay. And I kind of told you that's what I do. I said that in the very beginning. I don't like those reciprocal functions. I go right to sine, cosine, tangent. He did it, and now, what'd you write over here?
3 over 2 squared root of 3.
Okay, look what he did. He wanted to work with this ratio instead. This function, cosine, is a reciprocal of that one, but you have to take the ratio and flip it. So he does it. You know what, though? That's not a good look. Let's get rid of that radical.
Why letters?
Okay, and if you did that, you're really looking at what now? 3 square root of 3 over, that's 3, times 2 is 6. This reduces to what? Right? Whoa, what am I doing?
Yeah,
Didn't mean to write that, sorry.
Now you're gonna take your separate and do it. And the radicals on the bottom.
Square root of 3 over 2, right? Yes.
2
No,
squared root of 3 over 3.
3.
Square root of
3. There we go. Got it. So here's what you're doing. So what angle gives you this? You're talking cosine.
30.
Is it the 30?
Yeah.
Okay, let's try it. 30, cosine is adjacent over hypotenuse, which is exactly what you have. The answer is 30, right? And see, it is so much easier to me, just to go with the big 3, sine, cosine, tangent. You can work that one out if you want. It's okay. This would be hypotenuse over what? Adjacent. And then you'd have to sit there and play with it and go, okay, here's 30. What's the hypotenuse? 2. What's the adjacent? Square root of 3. And then, of course, you'd have to go, is that really that? And it is. So 30 is the answer. But see, that's hard. I think that's harder to do. I don't think I'd do that if I was you. It's up to you. You'll see what I mean when you get to your assignment, I promise. If you keep working with those reciprocal functions, you're going to get confused. Cofunctions. What are cofunctions? They're functions that kind of go together. So these two functions go together, these two go together, and these two. Sine, cosine, tangent, cotangent, secant, cosecant. They go together. Now, when you read this theorem, it's kind of cool because if you ever see this in your assignment, you can always convert one back to the other. So cofunctions, right here, of complementary angles are what? They're equal. So if you have cofunctions, this, or that, and they're if you do complementary angles, they become equal. So here's what I'm saying. Sine of 25 degrees should equal cosine of what? Why? They add up to 90. Okay, punch it in right now. Sine of 25, what is it?
0.4226.
Point what?
422.
Punch in cosine of 65.
0.4226.
Ah.
2.
Okay, so they're equal. As long as they're cofunctions, and cofunctions have to go together, cosine goes with sine, cotangent with tangent, cosecant with secant. As long as they add up to 90, they're the same, okay? Answer the other questions, and I think can you see them or not?
Miss Rader.
You have them? Yeah, go ahead.
Like when I pretend my computer, I don't get that.
You don't get what?
The right. I get like different.
You get different answers? You're in radians.
Right.
Go to mode, get out of radians, go to degrees. Okay, tangent of 50 should equal cotangent of, right, 40?
Yes.
They have to be complementary. 40 plus 50 makes 90. Okay. Next one, cosine of 28 subtract sine of 62 is, no, Paul,
I was just
don't
clearing
touch it. You guys, you're not supposed to punch this in, you're supposed to know the answer. Why 0?
I don't know.
You're right.
Ooh, I know why.
Why?
Because when you add sine 62 to each side, then you have 90, and you can't have a third term because then it won't equal
Okay, wait.
90.
This and this are complementary. They add
Right.
up to 90.
Right.
These are cofunctions, they go together.
Right.
The answer to this problem will be what? The exact same number, whatever. I don't care. Same
So if you set
number minus the same number, right? I don't care what it is. Let's just pretend it's 0.426 minus 0.426. You're gonna get what? 0. Yeah. You don't even have to know what it is. You just have to know they're the same. Same minus same is 0. Yeah? Okay.
I'm just checking that.
Use your calculator. Now you can touch your calculator. Go figure out sine of 34 degrees in 22 minutes. Go. I'll turn you loose. See if you can do it. I'll catch up.
Wait, how do you get 50? Wait. No. I like the degrees. Oh,
Okay, you ready?
it was like.
Will
No.
let the cat out of the bag when he said, I don't get that answer. So then I had to tell him, get into what? I had to tell him, get into degrees. His calculator was in radians. You are in what? Degrees. Get your calculator in degrees. Hit the word mode right here. In mode, you're going to see right there, I'm in radians right now. I'm not going to get the right answer. I got to get over to what?
Degrees.
Degrees. So down 3 over 1, got it, enter. Now I'm in degrees, I should get the right answer, unless I hit the button wrong. Okay, clear? What was it? Sine of what?
34 degrees.
So hit 34 second app, which is angle. You want degrees, number 1. Then 22 what? Minutes? Second app, number 2. You good? Hit it. 0.564, good enough. 0.564 is good. Do you realize that's a ratio? Do you realize this is what just happened? You've got theta. Oh, I suppose we know theta. Theta's right here. Okay? You know what this says to me? 564 over what? No? Are you looking? That decimal your calculator gave you is really a ratio. It says the opposite side is what? 564. And the hypotenuse is what? 1,000. I know you guys are seeing a decimal, but it's a ratio. Just so you know. Okay? Do the next one. Cosecant.
Wait, no, you do. But no, you do sine.
Oh,
What?
it's wrong.
Will.
Hint, look up. I don't do cosecant because there's no cosecant but
All due respect,
there is.
that's wrong.
Go to sine instead. Sine and cosecant are reciprocal functions. When you type this in though, you're gonna get an answer. It's wrong. It's the ratio for sine. You have to do what to it?
Flip it.
Flip it. Watch this. This is how you do it. Let's go here. Here's what I do. Sine of what? 80 degrees. Got it. I know I can hit enter.
Nope.
That's the wrong answer. That's the ratio for sine.
You didn't put degrees.
I don't have to put degrees. I'm in degrees. Look, right here. I'm in degrees. I don't have to put degrees. The reason I did before is because I had minutes and seconds. Then I have to do it. Okay? All right. Come on back. Let's go like this. This is my answer for sine. I know cosecant is. I got to reciprocate this. There's a button that will always reciprocate your answer. Is it what? No, don't do that.
Okay, I won't.
No, you guys, you didn't know this? You've never known there's a reciprocal button on your calculator?
No, my teacher, that shouldn't teach me.
It's right here. It's underneath math. X to the what? X to the -1. That is the reciprocal button. It just takes your answer and just flips it upside down. Ready? Enter. The answer is 1.015. So you have to hit this now, right? X to the -1, and then you get 1.015. And that's an approximation, right? That's what I do. I go back to sine, cosine, tangent. Okay? Are you okay?
Oh, you good?
What's your question?
I don't anymore.
What's this?
Cotangent.
Don't work with it. Go to what? Now look inside. Is that degrees? Radians. Get out of degrees right now. Right now. Go to radians.
What do you want to do there?
Okay, I wrote you a note. Somebody in period 4 said, are you going to give us hints when you want me to go from one to the other? There's no hints. You're supposed to look at this and say, that's radians. Why is it radians? No. No. No degree sign. If there's no degree sign, it's radians. That's what? Degrees. The other one, degrees. Guys, I can make this degrees. Watch this. There, now it's degrees. That's all I had to do. That is just a number, whatever that number is, degrees. I mean, that's how easy I can make it degrees. It wasn't degrees. Paul, put your toy away. Come on. Okay. All right, here we go. What's the answer?
Why is budget the focus?
Point
I did right here.
325.
Point what? 325?
No, it's 3249.
Is that what you said, Kyle?
Yeah.
Okay. Questions?
Wouldn't it be 5 over 2 pi because it's already 2 pi over 5?
No. You're thinking this. Here's what you're thinking. Cotangent of theta equals a ratio. Okay? I've got the angle. That's the angle. You don't flip the angle, you flip the ratio. When you type this in, you're going to get a ratio, and then you're going to flip your ratio to get your cotangent. Do you hear what I just said?
No.
Ah, shit. Okay.
Yes.
Okay. You're thinking, I've got to flip, like here. I didn't flip 80, did I? Did I flip 80? No. You're not going to flip your angle, you're going to flip your ratio. Your ratio comes out in front of you.
Oh,
Hit x to the -1, it flips. Okay? Go. Solve this triangle, get all the missing parts. The missing parts are alpha, that's angle alpha. What else is missing? Side B and side C. Alpha's the easy one, by the way. That should be like, no problem. All three angles equal what in a triangle? Yeah, 180. We know it's 180. So I've already used up 90. I've already used up 34. What's left for alpha? 50 what?
6.
I think it's 6, isn't it?
Yeah.
Okay, 56 degrees is the answer. That should be almost a free point on a quiz, right? All right, let's get B. Now B, you got to think of your trig functions. You know this angle. You want that side. That side's the opposite side. You know this side's the what side? Adjacent. What function would you use? That's tangent. So it's tangent of 34 degrees equals B over 6. Opposite over adjacent. Now that is an equation. How do you solve that equation? Multiply by 6 on both sides. Knock out the 6's. B is roughly, get over here, multiply by 6. Oh, by the way, you're in radians, because the last problem you did was in radians. Get it out of radians, go back to degrees. I'm pulling your teeth. Come on, guys. Give me some answers.
4.05.
4.0 what?
5.
5. Okay. All right. I got B. Whoops, I got B. Now let's go get C. If you want C, you got to look and go, I want the what side? Hot. I know the adjacent. So hypotenuse and adjacent are what? What? Cosine?
You have to use 34 or should you do the?
Well, that's the given angle. You could have used this one, but what if you got that wrong? What if you didn't call it 56? What if you called it 58?
I wouldn't.
Well, oh, sorry. Let's do it quick. Ready? It'd be 6 over C times C, knock them out. Times C. Divide by what?
Cosine 34.
Cosine 34. What's the answer?
But you do 6 divided by the cosine of 34.
Yeah, but what's the answer?
You want to help me with
7.4.
4. Got it. We're done. That's it.
So, Paul, we're going to make your promo progress today.